Okay, so my first question today is how about graphing logs? All right, so if I had to graph this, I bet a lot of you couldn't. So let's review how you'd have to do that. First off, what's your best friend in all graphing? XY chart. Especially handy when you don't remember what they look like. I remember what it looks like because I have it memorized. And if you're just a good memorizer, here it is. That's generally what a log looks like. Remember the tree blown over in the wind kind of thing? Okay. But how would you get that if you hadn't remembered it like I did? You'd have to go and make some XY points. So if I stick in X's like 7, that's really dumb because it doesn't work out nice. What would work out nice? Yes, 3 is a good thing to stick in, so I'll put in a 3 in my chart. Everybody, stick in 3. Hint, give them some other things that work nice. If you've won the argument, you get nothing. All right, good. And there's one other thing we can put in for X that works really nice. Actually, 1/3 works nice. You're right. And there's one other thing that works nice. 9. Very good. Try those 4 spots and see if that jogs your memory on what logs are like and then how to graph them. All right, you got a headphone in. It needs to go. Thank you. All right. I'm going to pause for a sec. Okay, so if you put in a 3, what's log base 3 of 3? 1. If I put in a 1, I won the argument and I get 0. I get nothing, just like in life oftentimes. 1/3. I'm just saying, if you argue with people, especially unnecessarily, you'll probably just lose friends at a higher rate than normal. All right, so if I put in 1/3 right there, that's 1/3 to the, actually I'd change it to log base 3 of 3 to the -1. That means the answer is -1. How many of you knew that the 1/3 would give you a -1 power? Awesome, then you know something about exponents that are weird. There's fraction exponents on this test, and there's negative exponents on this test. Negative exponents are just where you have to flip them, like 3 turns into 1/3, that kind of thing. All right, and the last one, if I stick in a 9 right here, it's log base 3 of 9. I hope you know that pattern. If that's 3 squared, then the answer must have been 2. All right, and then when you graph them, they look something like that. Okay, so that's graphing logs. That was a very good question. So find another thing that we haven't talked about in a long time that's on the packet, because that means it's probably on the final. And that was one that was not done in any of my other classes, so that was a good question. Yes. Go ahead, sir. Yes. And here's an example of one. That's a $200,000. Can you tell me if it's a loan or an investment from looking at it so far? Nope. But when I do this part, u sub n equals u sub n minus 1. Wouldn't it be nice if this was all in your calculator? Because then when we have one like it that says like, oh, it's a 5%, no, 4% interest, you'd just be able to change that to a 4. You know what I mean? Let's do that. So everybody grab your calculator and put it into, not funk mode, that's what James Brown is in, and you probably are too. We need sequence mode. Go over to SEQ. So function, sequence, hit enter. And then I go to y equals, and it'll be that. Now you're in sequence mode. The most common hard questions that we'd have on a final like this would be those real world questions. So they have use of zeros. So your top number, the n min, that's a 0. Again, that top number there goes with this number here. That's the little n numbers. And min means smallest. So it's saying smallest n. Smallest n is 0. See, because we have a 0 there. Do you have to always have a 0 there? No. That could be a 1 is another common. U sub 1 is really common. But okay, back to this. N min is 0. Put that in. Then this is a little blinking U. It's only blinking because my cursor is on it there. But this has to be parentheses n minus 1. Common mistake here, some kids put the capital U. It will not work. capital U is different than lowercase u. You have to have a lowercase u. It's above the 7 key. And then I have 5% interest divided by 12. What does the divided by 12 mean? Monthly. What if they change it to quarterly? You change that to a what? A 4. All right, good. Then the minus here is telling me that I have $2,000 payments. That's the only way you can tell that it's a loan and not a, that's supposed to say 2,000, it's just it wouldn't fit, so here, I'll write it again smaller. Okay. So, if you put this in with me right now, it'll make your life so much easier because even when you quit out of sequence mode and go back to function mode, it'll stay here. It'll be sitting there waiting for you until you need it. Okay? And then if your problem becomes 5% interest, cool, you've already got it in there. But if it's 5.5, it's pretty easy. Just go in and I'll have to retype everything? No. You can just do what's called insert. If you haven't learned that, it's really handy. It's right above the second. It's second insert. Let's say it's 5.5%. See how I just can put 5 in there? It doesn't wipe everything out. If you haven't figured that out, it's insert. It's right above the delete key is INS. It's kind of one of those little handy tricks that I'm going to remind people of in my ACT class this summer. All right, so there's a lot of little calculated things that can really mess you up or help you a lot. This is a $200,000 loan. Is it paid off like in 1 month? No, it takes a long time to pay it off. So I'm going to save you a lot of time and tell you where it gets paid off. Everybody go to table settings and make it 125. That's not exactly where it pays off, but if you go just put your table settings to 125 and hit enter, and now go to the table, I want you all to put this one in, and we're going to do a question together about it. I'm going to get it running here. If your calculator's running for a really long time like that, you know why? It's because it's trying to get in shape. Okay, actually, if it's running for a really long time, it's probably just because it's trying to calculate 143 different values. Because you go to 130, it also has to do the ones that are on the chart, you know, like the rest of that chart, the rest of that screen. So there, it's taking a while because it had a lot of calculations to do. Where is the key moment on the chart? Where it finally turns what? Negative. And right here, it turned negative. In the real world, it was you mailing checks to the bank. What happened right there? You paid it off, and what happens with that negative? They owe you that money back. They owe you $742. After you made your payment of $2,000, they owed you money back. That happens, honestly, for a lot of people on their last loan payment. They mail in their check, and then it's like, instead of, oh, I still have to mail another check next month, they get a check back. And it's like a little less than what they paid, but it'll be their final refund, and then they're done, and they don't pay anymore. It's a big moment for a lot of people in their lives when they finally get the house paid off. Yes? So are you? Oh, I get what you're saying, but no bank that does that, as far as I know. But I kind of like the idea. You just keep paying your $2,000 a month, but they'll just stock it up for you and invest it in stocks or something. It's not a bad idea. You might be able to, you know, like use that at a bank someday to like say, all right, I get the special. Maybe you could even like make the loan a little cheaper if they agree to do your little thing at the end, where we'll make your little loan a little bit cheaper along the way if you'll agree to keep it going after it's done, and we'll save it for you for like a couple of years. Okay, so hopefully you were smart enough to know that 130 was kind of a big deal. If I had just said how many payments, it would have been too simple. Here would have been the question. How much total did you pay for this house? You didn't pay $200,000 for the house. You paid 200 and something. Figure it out based on that 130. the payments that you were making, and how much money they owe you back. Get a final answer number, and I'm going to pause for a minute while you try that. Okay, here we go. You should have said 130 times 2,000, but if you just did that, that was a little oversimplified, because that's not factoring in that they owe you back. So minus 742.09. If you said 10 cents because you saw in here that it was a 0.1, do you get that it was rounded and we're only different by a penny and it's not that big of a deal? If it was multiple choice, we wouldn't have had it two different answers that were only a penny different. That would have been cruel. If it's a free response part of the test, which there is some of those, then I would have accepted it a penny different. That would have been close enough. All right, final answer. 259,000 and anybody got the rest? 260. And then it's I'm not sure I heard that right. 257? Okay. All right. Yes. I hope you get that if you just think to yourself, oh, I paid off my house, that means I paid 200,000. No, you paid way more than that because of interest. That's why banks can like build big buildings and like downtown, like they name stadiums after banks and stuff, right? Because they make a lot of money on interest. That's how they make money. That's one of the ways. It's not the only way. They also make a lot of money on fees because people forget and they write a check that's too big for their checking account, and it does what's called bounce. Have you heard of that? They charge like a $60 fee or even more for, oops, you wrote a check that was too big for your account to handle. And they get so much money on those fees. Like if you do that, they charge you like $60. And you have to write another check. It's like, nope, that canceled, and then that chance is over with, and you owe us another $60, and now you can write another check. So anyway, and then oftentimes whoever was supposed to get the check is going to count that as a late payment too. And let me bring that up as one last little real-world example of this. You might get a loan for 4%, and this person had a loan for 5%. Why would you be able to get 4% and somebody else right next door to you might get 5% and you got 4%? Credit rating, yes. Your credit rating is a big deal. And I can encourage you just in two ways. It's really simple. Never have a late payment, even in high school. Okay, in high school, it's probably going to count for about 3 or 4 years. That means whatever you do in college, you're going to have a higher interest rate than the other kids that don't have a late payment. If you don't have any bills that are attached to your name, you can't have a late payment. But typically what happens is kids get a credit card in college. And then some kids are disorganized and they don't make their payments on the credit card. And all of a sudden, boom, they have a crappy credit rating because they aren't paying their bills on time. And all of a sudden, you graduate from college, you want to buy a house, and you get 5% interest and I get 4%. That's not fair. Well, it kind of is because you screwed up your credit rating and now you got a worse credit, therefore worse interest, which in this case is higher interest. So, don't miss payments. Here's the other thing. If you do get a credit card, don't max it out. If they have a maximum that they'll let you borrow is like $4,000, don't borrow all $4,000 because that's a negative on your credit rating. Like, who would you rather lend money to? A person who's got a credit card and they haven't even maxed it out, or a person who has already maxed out that credit card and wants to borrow money from you? You see what I mean? That makes sense that their credit rating wouldn't be as high as yours. And one last thought on the credit rating, a lot of people don't know this, but it counts on car insurance too. You're going to have to get insurance for your car. It's already expensive when you're young, all the way until you're 25, and then all of a sudden the rates go down to kind of normal adult rates. But up until age 25, you're going to pay higher rates already. What about a 40% increase just because you have bad credit? It happens all the time. That's a lot of extra money. Your car payments or insurance payments might be about $100 a month, but it might be $140 if you have bad credit. That's a big deal. That's one of those moments where just being smart can save you a ton of money. Good credit. Okay. So, do you get if the question had not been how much did you pay, but if the question had been how much interest did you pay? At this moment, you would just subtract 200,000 and you'd be able to see how much interest you paid. All right. That's all you'd have to do. 259,000, you'd subtract the 200,000, and that's how much interest. All right. Enough about that stuff. Who's got another thing that they'd like to know? We should wrap up here in the next 10 minutes or so. Yes?
Much like the huge word problems where you have to like
Ah, yes. Okay, those are called linear programming. Here is a typical linear programming question. You got an equation for a line that goes like this and another line that maybe goes like this, and they've shaded, and you're smart enough to know that it can't be negative because we're talking about like selling toasters or something. And so then, therefore, it stays above the lines x equals 0 and y equals 0. But the key moment, this isn't that hard because it's y-intercept. The two ones that are hard are this. That's an x-intercept. Finish this sentence for me. The x-intercept is where y equals 0. You stick in y equals 0 in the equation and you solve it. That's not that hard. But this one, this is the moment you have to see, do you know how to do second calculate intersect on your calculator? Let's see if you do. I've got one that's all pre-made because another class asked this one, but it's a very good question. So I'll show you this, and I'd like you to type it in your calculator and see if you can do second calculate intersect. And if we find somebody's calculator is not working right, now's a good time to fix it instead of during finals, right? I'm going to pause while we pull up that question. So here's one where I've got a y equals equation that's black and a y equals equation that's blue, and we want to see where they cross. Use your calculator to type those two equations in, and then do what's called second calculate intersect. And that should give you the spot where they cross. I'm going to go to do that first. I'm going to go into mode and get out of sequence mode. And don't worry, sequence mode is still going to have that equation in your calculator later when you come back to it. I'm going into function mode. And I go to y equals. And now I can type in those two equations. I didn't do it super accurately, but it's a little faster because 1/3 I put in 0.333. Don't forget these slopes are negative. Type those two in and see if you remember how to do intersect. It's above the trace key. I'm going to pause while you give that a try. Okay. I'm going to go to my window and on purpose mess it up. Because this is going to happen to a lot of people. They're going to hit graph. Maybe it's on the ACT or maybe it's on this final. And they're going to hit graph and they're going to be like, I can barely see where they cross. Well, if you can actually see where they cross, at least you have a chance to be able to do it. Do you get that if you want to make sure you can see where they cross, you sometimes have to go into the window and then like try to figure out what numbers need to go in here to make it work better? So if I could go further to the right, which is X, then it would be easier to see. And then I'm going to hit graph. And now I should be able to see really clear and easy where the two things cross. Okay. And now I go to second, calculate, intersect. And that's the fifth option there. And I wish it just jumped right to it. I really do. But all you have to do, if you've only put in two equations, is hit enter, 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 and it'll jump to the answer. It's asking first curve, yes, you're on the first line. Second curve, yes, you're on the second line. And then I ask guess. You don't even have to do this, but you can if you want to. Move over closer and then hit enter. And boom, there it is. 17.96. Wait a minute, some kids say, but mine says 18. Well, maybe you put in exactly 1/3 as 1 divided by 3. You know what I mean? If you were more exact on what equations you put in, then you'll get a more exact answer. All right, so 18.1 is really close to what I said, and that's actually the right answer if I hadn't rounded. You know what I'm saying? All right. So, what is that? Well, that's the corner of the feasible region. What if the optimization equation was something like this? It costs money to make these x's and y's. Which way should we do it if we make the same amount of money total? Which way costs the least? So you're trying to minimize costs, and you now have this point that you figured out is at 18 comma 1. Sorry, 18 comma 1. Well, then how do you minimize costs? You check this corner, and this corner, and you plug them into the optimization equation. Imagine for a moment it said that the costs were $5 for each x plus $8 for each y equals C for costs. You could figure out which of these three corners gives you the lowest cost? You stick in a point like 18.1 and you put 18 here and 1 there, and you figure out the total cost for that, figure out the total cost for the other spots, figure out which one's lowest. You guys rocked this test, but it was a while ago, but overall the scores were really high. So, yes?
So how do you know whether you use the y-intercept for the black or the blue?
Okay, here, it's simple. What axis is this line right here, this one that's running this way? What axis is that?
X.
Then this spot is the x-intercept. And it's the x-intercept of the blue one, right? And so I go to the blue equation here, and if I want the x-intercept, finish this sentence. The x-intercept is where the y equals 0. So I put a 0 right here, and I can solve that equation.
How do you know that the y-intercept of the black line is the corner of the equal region?
Is this spot right on the edge of the shading? No, it's not. That's why it's not. That's not it. Because it has to be right on the edge of the shading. That happened on one of your tests too. There was a lot of people that we had this one that was like this, and we had it shaded in, and then this one, a lot of people put in the coordinates for that one as one of their answers, and that's not on the feasible region, so it's out. This one can't work because it's not shaded there, so this gets thrown out. All right, that was a good question. Just got another one. Yes, ma'am. Yes, here's a typical variable in the matrices problem. 2, 1, n plus 1, 7, 4 equals 13, 15, 20. Now, first of all, this is a valid question, but is that the kind you meant?
No, like the one where
They give you the equations, and then you have to stick the numbers into an... Sure, go ahead and find it. Just for perspective, though, do you get this would be 2n plus 4 equals 20. I just pulled that from here. And then you could solve the variable that way. That's one way you can have variables in them. Give me another way.
Like, so it would be, it's like a 1 by 3 where it's like 8y, and then it's 3 by 1 where it's 5 negative 6.
Okay, and does it give you like an answer for it? Oh, so it just wants you to write what the answer is. All right. So first of all, I'm glad you said that it's a 1 by 3 and a 3 by 1 and whatever. So let's write those out again. This has got how many rows? 1. By how many columns? 3. This one's got how many rows? 3. How many columns? 1. If these match, your answer is a 1 by 1 matrix. First of all, do you get that? Because I saw an ACT question the other day that was just about that. It was like, which of these matrices can be multiplied? Okay, good. So we can multiply it, and our answers are 1 by 1. So then our answer is something which is an expression, it's called. It's like it's got a K in it, or it's got a P in it. In this case, it's got a Y in it. So you tell me, if I'm going to get this one, which is a 1 by 1 matrix, so that is spot 1, comma 1, I'm going to use this row and this column, and then the 8 and the 5 and the Y and the negative 6 and the 2 and the Y are all going to get put together. Yep, whenever you do these matrices, you multiply and then you add. So 5 times 8 is 40, plus the Y times the negative 6 is negative 6Y, plus 2Y. And you put them all together, and then that becomes negative 4Y, so it's 40 minus 4Y. Make sense? All right. Okay, and if I'm going to leave you any time to work, I'm going to probably need to stop here. So, congratulations, you just made it through your last math class this year. Now it's just the final. All right, that's all I got for you for today.